This talk this evening is about Göbekli Tepe, and my question is it the world's first sacred geometry? Things are getting older and older. The recent discovery of, or the recent presentation of the Gunung Padang Pyramid in Indonesia, to date from 25,000 BC, really pushes things back in a totally different way and gives a different perspective on the origins of humanity. But Göbekli Tepe in southeast Turkey was one of the monuments that started that out, with incredible discoveries, as you can see in these pictures of these pillars, which were totally buried underground on the hilltop. So Göbekli Tepe is in southeast Turkey here, in between the Euphrates, which runs down this side, and you can see the Tigris River running down this side, and you have the Fertile Crescent, which is between them, which is where further south there was Babylon and Sumeria right in the south. Now, Göbekli Tepe, we'll see later, is the first monument of its kind to have been discovered in the area, but now many other monuments like this are being discovered, and that's what I'm going to be talking about a bit later on. Here's an aerial view of this mound, which is an artificial mound on the top of the highest point of the Jurmas Mountains, and it's an incredible achievement to have brought all these stones up to this high point here. This is a drone image which was filmed especially for my new film, which will be coming out at the beginning of 2024 in a new version. And inside the mound, once the digging had started inside the mound, what was discovered was just totally mind-blowing. These pillars, T-shaped pillars, some of them, the highest I think for the time being is 5 meters 50, but it is thought that in the center of the hill there may be one 12 meters high. These pillars are arranged in not circles but circular shapes. They're not perfect circles, they're different geometrical forms, but they have larger pillars in the center, as you can see. There are smaller T-shaped pillars around and larger pillars in the center. The amazing thing about Göbekli Tepe is the date. The actual T-shaped pillars were thought to have been erected 11,500 years ago, so 9,500 BC. And the whole thing was covered over by dry stones 10,000 years ago in 8,000 BC. And of course there are these incredible engravings which are very sophisticated and don't show signs of sort of primitive behavior. Here's a photograph taken under one of those roofs, and you can see all the stones that make up the cairn that totally covered over this monument and had hidden it from view for so many millennia. You can see how at the base of these T-shaped pillars they were put into flat stones which had holes in the middle. So the flat stones were placed on the ground, and then the vertical stones were wedged inside them. And you have two T-shaped pillars opposite each other, which create this kind of geometrical shape in the center of the enclosure. Now this is a lot like the monuments you find in Minorca. Here on the left you can see this T-shaped pillar in Minorca, and around it you have a circle of pillars. This is very similar to what was found at Göbekli Tepe. The difference here is that these things are dated to 100 AD by what has been found on site. The Göbekli Tepe question, of course, the discovery of Göbekli Tepe makes one wonder if what is to be found in Menorca is not a lot older. And then Stonehenge, the same principle, a circle, and inside these pillars which are higher than the ones outside. Another incredible thing about Göbekli Tepe are the sculptures that have been found inside. This one is a very strange one of what looks like a human being kind of held from behind by some sort of strange being. So this has given rise to all kinds of ideas. There are some beautiful stone circles like that have been found, and then representations of humans. This is the Urfa man. He's called the Urfa man. With he has black obsidian here in the eye holes like that, and he has a V-necked sweater. He may have a beard here. We don't see his mouth. But he certainly doesn't look like the typical picture of a prehistoric man from 12,000 years ago. This on the left here is a head, a sculpted head, which was found. The skull, and on the back you can see this snake serpent, which is going up the back of the head. And it obviously reminds one of these headdresses you find in Egypt with the uraeus, the serpent, which comes up over the head and stands in the front here, the place of the third eye. This is another stone that was found, a sculpture, which is incredibly detailed. Could it be some kind of hairstyle? And this is a wood sculpture showing a sort of tortoise with a giant turtle, and they're having a party with it. So you can see how this site at Göbekli Tepe fits into the countryside. It's on a high point. I'll be coming back to this. It's very important. And you can see how the central pillars here on the right are aligned. Now, two Israeli archaeologists from Tel Aviv University, Gil Hackley and Avi Gopher, did an incredible experiment inside the Göbekli Tepe circles. They applied what's called formal analysis using the latest technology to reconstruct aspects of the architectural design processes involved in the construction of the monumental enclosures. So what you can see on the left are images from their paper. And you can see the red dots. These red dots are captors that they put around on the circles. And then they had a device which they would move around inside. And once it was perfectly at the center of those different captors they'd positioned, then it would give out a signal. And so doing so, they managed to determine the exact geometrical center of these different stone enclosures, which they called B, C, and D. Okay. Now, when they did that, they discovered an underlying geometrical pattern which links the three centers together, an equilateral triangle. So the distance between the centers of these three enclosures is identical. So that was quite a shock. And they discovered, then they concluded, of course, that from this simple fact, it had to be accepted that the three enclosures had been planned and initially built as one single project, that these weren't sort of later additions and bits were added on, because there were a perfect equilateral triangle between the centers. Then the whole thing had been planned from the beginning. Now, here what you can see is in red are the lines which link the exact centers they discovered, and in blue is an exact equilateral triangle. So you can see that the equilateral triangle isn't exactly perfect. It's very, very close, but it's not exactly perfect. So the angle B here is slightly inside, you can see, so it's slightly bigger here than 60 degrees. Whereas here the blue line is inside, so the angle here will be smaller than 60 degrees. And the difference is very, very slight, and so they didn't really pay attention to that. But they didn't wonder why this triangle was orientated in the way it is. They didn't think that it was interesting to look into the orientation according to cardinal directions, and they didn't suggest why it wasn't perfectly exact. Now, in this talk, that's what I'm going to do. I'm going to show you that the triangle is not an exact equilateral triangle because it was done using a different method, which is called modular geometry. And this modular geometry will give a much better relationship between the centers than the equilateral triangle suggested. And I will show that it's linked to the cardinal directions. Okay, so we'll see why the equilateral triangle is not perfect and why it's oriented like this. It becomes, consequently, for the moment, the oldest example of modular geometry to have been found some 6,000 years before the start of the Sumerian civilization. So as far as sacred spaces go, one that's very well known is Moses' tabernacle. It's the first one that's talked about in the Old Testament. And what's clear is that if orientation is very important, the sides have to be orientated to the cardinal directions, and the proportions that are given for Moses' tabernacle is a rectangle. The base is a rectangle which is 3 times longer than it is wide. 10 cubits wide, 30 cubits long. It would seem that the creation of any sacred space or temple is indissociable from sacred geometry. In other words, you can't create a sacred space without sacred geometry. And this fact is very important because it positions sacred geometry as the basis of sacred space. Okay, and we can see, for example, the pyramids of Egypt, very well-known example of how they're perfectly oriented on cardinal directions. They're very old examples, and I've shown how in Carnac, the megalithic alignments in Carnac were based on the same principles. This is the Giza Plateau and the Khafre Causeway here. And modular geometry is simply the principle of placing squares side by side, either side by side east-west as here, or north-south, or both. Okay. According to the number of squares which are used, the architect expresses a different symbolic meaning. This architectural method is based entirely on whole numbers. That's very important. It avoids the use of irrational square roots which are present in the equilateral triangle. For example, if you want the height of an equilateral triangle, then you take the square root of 3 from half of the side length. Okay, if half the side length is 1, then the height of the triangle is the square root of 3. which makes exact equilateral triangles difficult things to work with on an exact basis. So seeing as Göbekli Tepe is presented as the world's first temple, then it would seem natural to check if the ancient principles of modular geometry were applied there. Now here you can see the higher pillars in the center of the enclosures, and I've drawn this yellow line to show how they're aligned. You can see it here in a picture. On the right here we have the plan by Hackley and Gopher, and on the left here is an aerial photograph, and I put a red dot to position the center of the enclosure as they found it. Okay, because we're looking from one side, we're not getting an above view exactly here. The pillars go under here, right? So what we can see is that these pillars, inner pillars, are aligned. Okay. And Hackley and Gopher then did this the blue triple square is my add-on, okay, but the rest is theirs. The measurements of 2.8 meters. They discovered that there was, between the inside of the pillar here and the inside of the pillar here, there was 5.6 meters, and that was the same distance, 2.8 on either side, to the edge of the enclosure, and that the center was halfway between those two pillars. So there was clearly a detailed organization, including the whole enclosure. Okay. So it was possible to establish that the angle of the base of the equilateral triangle was the diagonal of a triple square whose sides are placed on the cardinal direction. So you can see the north here on the plan, and this triple square is placed with the one side north and the three side east-west, okay, which gives us a perfect orientation. Well, it's not exactly perfect. Their line is the dotted red line, and it makes a difference of half a degree. Now, I wonder, was their north absolutely perfect? Anyway, I'm quite convinced that the intended angle for the base here was the angle of the triple square. It's too close to be something else. From their measurements here, we can determine that each square would have a side length of 3.54 meters. This is the same orientation as the tumulus Saint Michel in Carnac, whose base is again orientated on a triple square like that in red here, placed on the cardinal directions. This is an image from the forthcoming film showing the different points that were used to measure these centers and how it was done. Okay, so here we have Hackley and Gopher's geometry for the three enclosures. So you can see how the triple square links the four central pillars. This one is slightly goes over, but three of the four are exactly aligned on that line. The dotted blue line here, which was on their plan and which is an axis, they explain that it's perpendicular to the base, but they explain a bit further down here that they have found structures in the ground which would seem to indicate the use of this axis. Well, this axis is the diagonal of a triple square, a vertical triple square, which is cornered at the center of the northern enclosure. Okay. Now, what I discovered first was that if from point B, the center of enclosure B, I trace a five-fold square, so 5 squares one above the other, that will trace the exact diagonal between the centers. Okay, so we have a triple square for the base and a 5-fold square for this side here. Okay, that will give us an angle of beta here. I've called it beta, which is the angle of this triangle, and we can calculate that because it's the angle, it's 90 degrees, a right angle, minus this little angle of the quintuple square and this angle here of the triple square. So if we do the calculations, we get a result of 60.255 degrees. Okay, so this angle here, according to this geometry, 5 squares and 3 squares, we get an angle of 60.255 degrees, slightly greater than the 60 degrees of an equilateral triangle. And so that corresponds better to the positioning of the centers as they found. Okay? So then I had to work out, well, how was the line between D and C drawn? I discovered it was drawn using an 8 by 9 rectangle. Okay, so 9 on the east-west and 8 north-south here. These are squares, 8 by 9 ratio. If we do that, we get an angle delta here, which can be seen as the angle of the 9 by 8 rectangle plus the angle of the quintuple square, which is that plus that, 59.68 degrees. So here, slightly less than 60 degrees. And we can add the other angle as well, which I've called gamma here, okay, which is 8 over 9 plus the angle of the triple square, 41.63 plus 18.436. Now this gives us an angle which is virtually exactly 60 degrees, 60.065 degrees, less than 7/100ths of a degree difference from the exact angle of an equilateral triangle. So here's the triangle as drawn using modular geometry placed on cardinal directions. Okay. Of course, the total of those three angles is 180 degrees because every triangle has the sum. The angles of a triangle add up to 180 degrees. This is the sort of mathematical way of saying this, okay, for anyone interested. And if I superpose Hackley and Gopher's plan over the geometrical plan, what I've done here is my green line, which is the diagonal of the 5-fold square, I have exactly placed it over the red line, which was the line between the two centers. Okay? The blue line, which was their perfect equilateral triangle, is slightly outside of that. Okay, so this shows how this modular geometry fits perfectly the results they found. Okay, now there's a little difficulty with the center of circle C, and I came to the conclusion that maybe on their plan, the actual drawing that they gave, there was some sort of slight error on the drawing. I have mentioned this to them. This is the result of that. So we can see the three angles. I managed to calculate the measurements. So between D and B and D and C, there are only 4 centimeters difference. But between B and C, it's much shorter. It should be, by calculation, 19.1, but on their plan it's 18.64. So I get the impression that there's some kind of error in the way they drew their plan. Okay. So it's logical that BC would be slightly shorter because this is not an angle of 60 degrees. It's slightly less, 0.33 degrees less than 60 degrees, which shortens this length here. The squares used, this is modular geometry, the squares used can be seen here to have whole number relationships, which is always interesting to discover. The small squares of the 8x9 to the big blue squares, or the bigger blue squares, have a 33 to 14, so 33 of these square sides is equal to 14 of these square sides, whereas you need 53 of them to make 14 of the big orange ones, which gives a relationship of 53 to 33 between the blue and the orange squares. So these are whole number, exact whole number relationships, which is interesting. And this enabled me to calculate the size of the outer square, or the outer rectangle, which will enclose the triangle. And we see it's not a square, it's 55 by 53 units. Okay. This geometry dates back to 9500 BC, so that's something it's worth reminding you of. Now, from that, so I had presented that geometry already in a paper I put on Academia. I've never done a talk about it before, but I had written it down and put it in a paper. Now, over the past few years, a whole new lot of archaeological sites dating to the same sort of time as Göbekli Tepe have been found in the area. They have been called the Tas Tepeler sites. Tas Tepeler means stone hills. And for the time being, there are around 14 of them in this particular area, and they go around Haran Plain. And that's a very ancient plain, which was known in biblical times because Abraham left the city of Ur to come to the town of Haran here. Okay, so that shows how old things were here. Now, what I'm going to show you here is I'm going to talk about Harbetsuvan Tepesi here, and its relationship with Göbekli Tepe, and Tasli Tepe here, and its relationship with Göbekli Tepe. Okay, so that's going to be the final part of this talk. This is Harbetsuvan Tepesi. It's a satellite site of Karahan Tepe, so it's about 6 kilometers from Karahan Tepe. They have found here T-shaped pillars. The excavations that were carried out this year, 2023, have revealed that the site is probably even older than Göbekli Tepe and Karahan Tepe. We have the T-shaped pillars, and you see these walls are original walls. The hole that you see has been just dug out of the earth, so all this was just discovered. They've also, new geophysical data has revealed the presence of numerous unexcavated pre-pottery Neolithic enclosures. PPNB is pre-pottery Neolithic B enclosures. You have A and B, which are different sort of date systems, and enclosure walls. So these are very old structures, perhaps even older than Göbekli Tepe. We can see this is a sculpted stone. You can see angular sculpture at the top of this stone here from Harbetsuvan Tepesi. Now, between we have Göbekli Tepe at the top here on the left, and Harbetsuvan Tepesi here on the right. And you can see here that there is visibility between these two sites because you have the plain of Haran between them, and then you have some foothills, and here we come up to the highest point here at Harbetsuvan Tepesi, 35 kilometers away. So visibility between the two sites. That's very important. This is a picture taken from Harbetsuvan Tepesi where we can see Karahan Tepe as well on the hilltops. Now, the second site I want to talk to you about is Tasli Tepe. I've put here a picture taken off YouTube from a guy who does stuff about archaeology. He talks about Tasli Tepe. It's an 11,000-year-old site set to rewrite history. So what's special about Tasli Tepe? Well, they found T-shaped pillars there, but for the time being there have only been very small preliminary excavations. They found a lot of flints here, as you can see at the right, and this beautiful stone plate. This is a flat stone plate, 30 centimeters, so it's the same size as the Nebra sky disk. Has about a meter circumference. Around the circumference will be about 1 meter length, and that is flattened stone. So that's a beautiful discovery. The site is here, north of a town called Bashbuk, which is here, small town, and it's in the middle of agricultural fields here, so there's farming going on. That's what makes Tasli Tepe different to the other sites. The other sites are sort of on dry, arid hilltops, and so the excavations aren't really bothering people. Whereas here, people are farming this land. Now, this is the official positioning of Tasli Tepe. You can see the trees growing around the edge of this field, and then this separation here between the field. And this is the exact point I've taken to position Tasli Tepe. Here's a picture of it with the fields. Apparently the soil is 4 meters thick here. So the architectural digging, they're going to have to take away 4 meters of topsoil before they actually start hitting the bedrock or the level on which they could find the initial site. They seem to be very excited in Turkey about this particular spot. It would seem to be very promising from the different things they've found there, although it's quite a lot of work to excavate. Now, there is visibility also between Tasli Tepe and Gobekli Tepe. You can see it here at the bottom. On the left, we have Gobekli Tepe. There is a high point in between the two here. We can see a kind of ridge of hills, but they are not high enough to stop visibility right up here to Tasli Tepe. We come up a slope, you see, right up a slope here, and then we come to the top here. So again, visibility between the sites. Now I want to look at the visibility between Tasli Tepe and Harbetsuvan Tepesi. So Tasli Tepe is here on the left, Harbetsuvan Tepesi on the right. And here you can see that we're going along a kind of north-south ridge of mountains. So this is an important fact. I'll come back a slide here, because from Göbekli Tepe to the east, there is a north-south ridge of mountains here, which gives a very specific landscape organization, similar to what you find here, in fact, in Carnac, where you have the Quiberon Peninsula, which is north-south going into the sea, and which gives incredible visibility for sighting over angles. And you have the same sort of phenomena here with this north-south ridge, which is to the east of the hilltop of Göbekli Tepe. Okay, so there is one high point between Harbetsuvan Tepesi and Tasli Tepe, which blocks the view. It's here on the line. Definitely, if I were an archaeologist, I'd go there and see if there's anything to be found at this particular spot. You'll understand why in a second. So here we have Göbekli Tepe, Tasli Tepe, Harbetsuvan Tepesi here at the ground. The first thing I discovered was that between Göbekli Tepe and Harbetsuvan Tepesi, we have an exact angle with respect to cardinal directions of 2 by 3. So this is a very basic, one of the major geometrical shapes, 2 by 3. It's the shape of the ziggurat of Ur. The ziggurat of Ur is 2 units wide by 3 units long. And it's a very important shape in sacred geometry. And this angle, we have 35, it says 142 meters, but I've readjusted it a little since I made this slide. It's 35,180 meters. This is a perfect angle with 1/100th of a degree accuracy. And I'll show you this on Google Earth in a second. Now, the next incredible thing is that between Göbekli Tepe and Tasli Tepe, it's a double square relationship. So here, the north-south distance is half the east-west distance. So the combination of these two geometrical shapes to these two sites is really quite incredible. It can't be a coincidence to have the 2 by 3 between Göbekli Tepe and Harbetsuvan Tepesi. But when you add to that the fact that you have a double square to perfect accuracy, so I'll show you again on Google Earth. And here we have a measurement of 35,218 meters. And then between Tasli Tepe and Harbetsuvan Tepesi, this is a 1 by 16 ratio. So we have 16 little squares here, oriented north-south, and the diagonal links the two. What is absolutely astounding is that we have exactly the same measurement to 1 meter precision, 35,218 meters between Tasli Tepe and Harbetsuvan Tepesi. Exactly the same difference as between the same measurement as between Göbekli Tepe and Tasli Tepe. And as you can see, the southern line here is slightly smaller than these two sides, as was the case in the triangle inside of the Göbekli Tepe mound. Now, if we add those two angles together, that's the angle of a triple square, 26.565. That's the angle of a 2 by 3, 33.69. If we add them together, we get 60.255 degrees, which is exactly the same angle as the angle I found in the Göbekli Tepe inner triangle, which was created in the difference between the 1 by 5 rectangle and the 1 by 3 rectangle. Those two diagonals created an angle of 60.255 degrees, exactly the same angle as the one created here. But the geometrical shapes are different, but the angle is exactly the same. So that's really quite incredible. And it's possible, of course, to calculate the other angles, the other side of the triangle. Here, this is more precise than the triangle inside Göbekli Tepe. Apparently, it's on a much bigger scale, so we can get very high precision, because here we have 0.255 degrees over 60 degrees, and that difference has been divided between the two angles, okay? So we have 0.11 degrees less here and 0.145 degrees here. So these two angles, very close to each other in measurement, give you the exact difference according to this angle here. Okay, so there's the inner triangle of the Göbekli Tepe site with its 60.255 degrees, and then these two other angles. Okay, and this is the one given by the relationship between these three sites. So obviously this cannot be a coincidence. It's absolutely perfectly precise. I'm going to show you that actually. I'm going to show you that on Google Earth because it really is worth seeing, you know. So I hope you can see that clearly. I've now gone over to Google Earth here, and I'll show you now the lines that link. So we have Göbekli Tepe, Tasli Tepe, Harbetsuvan Tepesi, and let's take the line that goes from, say, Göbekli to Harbetsuvan. Well, okay, so we'll go from Harbetsuvan Tepesi. Apparently it's the older site, so we're going to zoom in. Now, I have superposed here the dig. Okay, so this is the diagram of the dig that was done at the top of the hill, and you can see that I have perfectly fitted it in to the landscape. Okay, you can see how the lines go through. Okay, so that is the exact positioning of the dig, and so that's this blue line here is Harbetsuvan to Göbekli. Where is it? Is that it? Hang on a second. Oh yeah, that's the one. Now if I look at the properties of this, it says, yes, it says that the measurement is 35,142, and so since then I have decided that this line needs to be pushed further this way. I think it's 35,180, okay, meters. That's going to be the position of it. So you can see we're right in the middle of the archaeological dig here. Okay. Now if I draw a line, well, let's do this. So I'll draw a line from here, and we're going to zoom right out and go right down to Göbekli Tepe. I'm going to put an older picture of Göbekli Tepe here because I've got an older satellite photo without the roof, before the roof was on. And so we can see here, these are the three enclosures, 1, 2, and 3. And I have put the line to the center of the northern enclosure. Okay, so that's Göbekli Tepe. I can go back down to Harbetsuvan Tepesi. It says 30368, and the exact angle is 30369. There you go. So my blue line was right. So that's the exact angle of a 2 by 3 rectangle, okay? So that's the first relationship. Now let's look at the one between Tasli Tepe and Göbekli Tepe. So we'll go up to Tasli Tepe from here. So this is the field in question. You remember, those are the trees. That was the limit of the field that we saw. And so this is the exact position of the Tasli Tepe site. So I'll put the line from here to Göbekli. Okay, apparently I've measured it from here. So let's go now to Göbekli Tepe. And we'll see we're going to go straight into the same enclosure, the northern enclosure, to exactly the same position. Okay, and here we have 243.44 degrees. If I do the, I don't know if you can see the, can you see the 243.44 degrees? If I take the tangent of that, you see it's 2.000. So we see we've got the exact angle to 1/100th of a degree, the exact angle of a 1/2 square. Okay, and the measurement, we'll go back to Tasli Tepe. Okay, the distance here, 35,000. I think it's 218, I said. There you go, 35,218 meters. Okay. So this is absolutely precise geometry. And now if we go between Harbetsuvan Tepesi and Tasli Tepe, so you see I'm going to go from exactly the same point here, and we're going to go down to Harbetsuvan Tepesi. So I go down to this point in the dig, and here on this line I have the same distance. Look at the measurements, 35,217 meters. There you go. $218. There you go. So that gives us this incredibly precise triangle linking these three sites. And you can see here how it goes down this ridge, this north-south mountainous ridge, which is to the east of Göbekli Tepe. So we can imagine quite well that from Gobekli Tepe there could be a whole calendar of watching the sunrise as it comes up over the hilltops here in the distance. Okay, so I'll come back to my presentation now. I wanted to point out that in Carnac there is an equilateral triangle in Carnac, which is has one of its sides has a north-south axis. Here we have a picture of it. So it goes between the cromlech, right at the west of the whole of the alignment system. It's the most westerly point of the whole of the alignment system. It goes up to the dolmens here of Manikerene. This is a perfect north-south axis. And then to the Géant du Magneau, which is the highest standing stone in Carnac, 5 meters 50 high. These are the angles involved, again slightly off the 60 degrees. The difference here is that the measurement used here between these two sites is 2,618 meters, which is exactly 5,000 Royal Egyptian cubits. Okay, and this is the shorter side. We have two sides virtually the same length, and again a shorter side here because this angle is smaller. It's a smaller angle, so the line here is shorter. And that's it. So that's what I wanted to present to you. I'm going to be doing shortly another talk about a different site in southeast Turkey called Karahan Tepe. The talk is called Karahan Tepe in the Origins of Christmas. But what we will see is that Karahan Tepe has also incredible geometrical relationships with Göbekli Tepe and other sites. But I think for one evening that's enough. So thank you very much for watching. If you enjoyed watching this video, then please like and subscribe by clicking on the link just here on my photo. And you can share the links, of course, with all your friends so that more people can understand the beauty of this forgotten knowledge which seems to have disappeared from our planet. Bye-bye.